right, type 2 of improper integrals. This is where we're taking an integral and there's a discontinuity either at one of the limits at A or B, or at A or B, or at somewhere in between A and B. So how do we handle that? This is how we handle that. If the discontinuity is at B, then we rewrite this as the limit as t approaches B from the left. It's on the left side of B that we're approaching our integral of f of x dx. And we up this integral from A to B to t right there. We rewrite it with that, with the place where it is discontinuous with this limit as t goes to B from the left. Here, if it occurs right here at A, then we'll rewrite this as the limit as t approaches A from the right of t to B of f of x dx. And if C happens to be somewhere in the middle, then we break it into two, and it looks like this. The limit as t approaches C from the left of A to C from the left plus the limit as t approaches C from the right. We pick it up from C to the right, and we go to B, f of x dx. So what happens here? Well, if the limit exists, then it converges to that value. If it doesn't, then we say it's divergent. Same here. Here, if either one of these is divergent, then if either one of these limits doesn't exist, then this diverges and does not exist either. So let's look at example 5, and it says determine if the integral from 2 to 5 of 1 over the square root of x minus 2. What happens with this guy? Does it converge? Does it diverge? Well, what's going on here? So we're saying this is the integral from 2 to 5 of 1 over the square root of x minus 5 dx. Now, it doesn't look all that horrible, except for when you look at it, you notice that if you put in 2 minus 2 is 0, and the square root of 0 is 0, and that's in the denominator, and so that is undefined right there. So that's a problem. So we need to rewrite this because we have a discontinuity and it's occurring at an endpoint. So we're going to rewrite it like we would for this middle one. So we'll say this is equal to the limit as t approaches 2 from the right, because it's on the right side of 2 where we have this situation, of t to 5 of 1 over the square root of x minus 2 dx. And now we use our integration skills to integrate this. And so what I'm going to do is I'm going to use u substitution. If I let u be x minus 2, then du is going to be dx. All right? Then that means I could think of this integral as 1 over u, or as u to the negative 1 du, which is the natural log of u. So basically when I integrate this, I get the limit, oops, I need to integrate it, as t goes to 2 to the right. When I integrate this, it's going to be, of u to the negative 1/2 is what that's going to be. So when I integrate this, because this is the square root in the denominator, so it's u to the negative 1/2, it's going to be u to the positive 1/2 divided by 1/2. So when you divide something by 1/2, it's like multiplying by 2. So this is going to be 2 u to the 1/2, but really it's not u, it's x minus 2 to the 1/2, or the square root is what I get here, and I'm going to evaluate this from t to 5. Okay, now let's put in our limit. This is the limit as t approaches 2 to the right of 2. And if you want to put this 2 on the outside of all that business, you can. And say this is the square root of 5 minus 2, which is 3, okay, minus, actually I could write this limit part over there. It doesn't, let me do that, because the limit didn't apply to the square root of 3, sorry about that. Square root of 3 for the 5, minus the limit as t approaches 2 to the right of the square root of 2 minus 2 is 0, basically. All right, square root of 0 is 0. This is a 0, okay. We get 2 times the square root of 3, so it turns out that it converges, this integral, therefore this integral converges to 2 square root of 3. That's what we get for that one. All right, that was nice. Let's do one more. Let's look at one where it is got a discontinuity in the middle of the integral somewhere. So let's have a look at how we handle that. This is example 6. Goes like this. If we've got the integral from 1 to 2, 1 to 2 of 4x over the cube root of x squared minus 4 dx. All right, so when you look at this, we have a discontinuity at 2. And so we're going to have to do the same thing here. Oh, I thought I had chosen one that was in the middle. Did I? I didn't, did I? I got to go 2 to the left. Let's just go ahead and do this one. All right, so 2 to the left is what we're going to have to rewrite this as. So this will be rewritten as the limit as t approaches 2 to the left, because 2 squared is 2, 2 squared is 4, 4 minus 4 is 0, we're dividing by 0, that's the problem. So we've got a problem at this upper limit. So we're going to rewrite this as the integral from 1 to t of 4x over the cube root of x squared minus 4, and then we will go ahead and integrate this. I'm going to let u be x squared minus 4. Then du is 2x. So if I need to rewrite dx, and if I need to rewrite this in terms of x's, of u's, I'm going to divide off the 2 and say 1/2 du is equal to x dx. So by u substitution, I'll deal with the limit stuff in a minute, but by u substitution, this is going to be, the x dx can be handled by writing 1/2 du down. So I'm going to write 1/2 du. What that got me was this x dx. And then I need this 4 as a constant, so I leave him. I just pull him outside. And then I have to write x squared minus 4, which is u, to the negative 1/3. Is what I get right there. Okay. So now that I've done this, let's integrate. 4 over 2 is just 2. The integral of u to the negative 1/3 is u to the negative 1/3 plus 1, which is 2/3, divided by 2/3, which is the same thing as multiplying by 3/2. And now we're going to evaluate this. I'm going to put it back in terms of x's and then put my limits talk back on there. So these cancel, so I get 3. The limit as t goes to 2 from the left of the cube root of x squared minus 4 squared from 1 to t. All right, let's see. This is going to be equal to, move up here, 3. Limit as t goes to 2 from the left of the cube root of t squared minus 4 squared minus, stick in the 1, the limit is, oh, I don't need the limit talk anymore because the t's not involved in that. The 3 will get multiplied to both. the cube root of 1 squared is 1, minus 4 is negative 3 squared. All right, what do we get here? We get 3 times, if I stick in close to 2 here, from the left or the right, it's close to 0, square root of 0, this gives me a big 0. So 3 times 0 minus, negative 3 squared is 9, minus the cube root of 9. So I get 3 times negative cube root of 9, or negative 3 times the cube root of 9. And this is what this converges to. Oh, come on. Minus 3 cube root of 9. That's what this integral ends up being. All right, so that's how you can handle improper integrals.